Good morning, friends. Now, try to understand what is electrical engineering and what is its implementation in railway. Teaching is a noble profession. I remember our ex-GM of South Eastern Railway, Sri Bhandari. I attended a meeting as a chief instructor of All India Central Training Center, Traction Distribution. Teaching is an art. However, you can attract the attentions of students with presentation, with interesting presentation and appearance. Also, the subject matter to inject to them joyfully. That is main. I remember the word Rasgulla from his speech. He has told when the lecture will be lengthy, then give some Rasgulla to them, means some sweet topics, make jokes and something to relax them. It is his view. He's a good professor in Baroda. So nicely he is teaching. But I have some drawback, like I cannot make eye contact with the students directly for few times. But it has been overcome with my animation in PowerPoint, AutoCAD. They can understand easily with this thing. Okay. Now I am thinking about electrical engineering. If transformer is the heart, then to keep heart healthy, you need good earthing arrangement. And electrical fault affect the power transformer, and with good earthing system and protection system, you can keep power transformer healthy. Any fault current, mainly the earth fault, bears huge fault current, mainly near substation. And if immediately not disconnected, fire accident and electrical installation can be made may be unsafe. And if you disconnect it, it will turn safe. Longer period of flowing fault current create fire accident, so many things, bursting of power transformer and huge loss of property, electrical installation, and maybe fatal to the human also. So transformer health depends upon earthing system and delaying with prompt isolation of faulty section. Next, I shall discuss how earthing saves human life as well as electrical installation. In basic, the short circuit. So what is short circuit? I have told repeatedly. When our circuit is working closed circuit with some load, it will reduce, it will maintain normal current, or maybe more than full load current, more than some full load current. In relay, our traction transformer is having the ability to take 200% overload for 5 minutes. But beyond that, fault current is huge amount of current, and you we have mainly the fault current. The earth fault is bearing huge current. But what is earth fault or short circuit? If your circuit is complete with specific load, that is design load that it can bear safely, then it is safe. But without beyond this load or very high, very minimum load, that means our traction transformer is having zero point 0.5 ohm resistance. But if our OHE directly come in contact with the earth, now you can think which huge amount of current it will bear. Suppose when the OHE has fallen in the ground and your impedance resistance is 10 ohm, then 25,000 divided by 10, because I is equal to V by R or V by Z. So it is how much? 25,000 you cut 10, that is 2,500 ampere. Huge amount of current. So normally fault current, the resistance is low than this 10 ohm also. So a huge amount of current will flow. Maybe 6,000 ampere, 7,000 ampere. And you know the heat generated is I square R. So the current will be I square. So huge amount of temperature will produce and fire accident may occur. Moreover, our return current is through the earth stuck to the earthing grid. It is just 600 millimeter below the earth surface. During huge earth fault, the upper portion will also be live somewhat, and the voltage between your two states may be dangerous to electrocute. Also, if you touch any support of the electrical installation, that voltage also be unsafe. It is called step voltage and touch voltage. So the purpose of the earthing is, in our railway traction, it is completing the circuit through the railway track as neutral to the transformer other leg through earthing mesh. But in domestic purpose, what we are doing? In domestic purpose, we are making earth the neutral position of three-phase system in star connection. And without any transformer, the phase to earth voltage is reduced to 230 volt. Here, after this earthing of neutral portion, the output can be taken from phase to earth and it will reduce to 230 volt. But if you connect phase to phase, it will around 415 volt. So what is the facility of the earth? You are getting phase to earth voltage in reduced condition. And again the same thing, if your phase touch the earth parts without any load or minimum load, then again short circuit current will flow. Your MCCB will treat and save the circuit. This protection system, our tripping device must be active so that during this earth fault, easily we can protect ours by isolating electricity from that section. So we are providing circuit breaker, some relays. Relay will sense the fault and open the circuit breaker. So I am telling about earthing. In our home appliances also, if you think about your water heater, its body is connected to the earth, because any leakage current from the phase, it will come to the body and go to the earth. It will not hamper you. Why? Because your body resistance is more than the earth resistance. Earth resistance is low, and the law of the electricity is follow the low resistance path or low impedance path. Your body resistance is more than this path, so electricity will not enter in your body, it will pass. But if it is disconnected, this earth is disconnected and you have touched, then you will get shock. So what is the facility? How earthing is helping our safety? So earthing is the main thing. After electrical insulated transformer, you have to provide safe earthing system with protective system. Then it is healthy system. In domestic purpose, we are earthing in our home also. Neutral point is earth in substation of the transformer, a three-phase system, but in home also we are earthing. Why? Because Earth is a continuous conductor throughout our globe. It can connect with each other without any wire directly where you have put the Earth in the neutral point and your live wire touch the Earth, it will go directly to the substation via this Earth, because Earth is a good conductor but not on the surface. It is somewhat inner portion of the Earth. It is around 3 to 4 meter this parent soil. It is a good conductor. What a beautiful thing. Without any other extra conductor, Earth is used as a conductor. And it is making us safe because due to its low resistance, we are not getting shock. But if the circuit is complete to your body, then you will get shock. Suppose face to your hand and your feet has touched the earth, so the current will flow through your body. But if your body is parallel of the fault path, you will not get shock because that path is resistance is very low, impedance is very low. It will protect you, this earthing system. But if you are in series with the face to earth, you will get fatal shock. So earthing is helping too much. Earthing is helping. So after the transformer is the heart, and we need earthing, good earthing system. But with this good earthing system, one story is there. A person ride in the temple and cannot get down from there. So your electrical system also, if you charge the system without isolation facilities, then it will be a problem. Any accident fault, you cannot make it dead. So next question is isolating system with the switches, with the isolators, with the circuit breakers, with the interrupters. So in electrical system, next thing we need is isolating system. Isolating system. This isolating system is also two types. For power circuit, some load switch is used like circuit breaker, interrupter. That means you can close open it anytime. If the circuit is closed, current is flowing, you can open it, close it. But the isolator which breaks in air, after making the circuit dead, only at the time you can operate it, because in the air it is opening, closing, and during opening when the air gap is small, because gap will create from small to high, a spark will take place and melt the blade of the isolators. So isolator is called no load switch, means you switch off the power, then only you can operate it. It is mainly used for making a circuit or breaking a circuit physically. You can see it physically, you can see it. But the circuit breaker and interrupter, inside the mechanism is there, and it is the contact is opening with some insulating material or vacuum. So you cannot see it, some indication is there, but isolator is helping you to see that it has opened. So isolation is the next important thing. After earthing, you keep good isolating system with protection system, then your electrical system is healthy. Next, what is next? Next is your design. How will implement your requirement? You have to design it. It should have some parameters so that the bearing capacity of the other things like load, equipment, everything. What is the requirement? And it is in safe condition. So we are designing circuit breaker, we are designing isolators, we are designing interrupters, we are designing our OHUR conductor size, we are designing our traction substation, other equipments like lighting arrestor, insulators, CT, PT. So all these things needs proper design. That means it can operate safely without harming the others. So today up to this, with some sketch I can show you. Now I have not the time, so now I am leaving it. Okay, thanks friend.
Comparison in between single phase 230 volt system and 25 kV traction system.